In this video, I'll go over kind of the why behind the fact that we sometimes flip the less than and greater than signs, and sometimes we leave them as is. So I'm going to do some numerical examples and talk about why is this what we do. So let's just start making some really obvious statements that we're all comfortable with by this point. 4 is less than 5. I think most students, by the time they hit Algebra 1, are really solid on that idea. Well, what happens is we do some operations to both sides of this inequality. Does it preserve this relationship? Because when we have an equal sign, there are a whole bunch of different things we can do. We can add numbers, we can subtract numbers, we can multiply numbers, we can divide numbers, we can square things. We can do so many things as long as we keep it in balance. But equalities are inherently unbalanced. They're saying this one is smaller, and this one is bigger, and this is specifically not in balance going a certain way. So let's try those operations, see what happens. What happens if I add 2 to both sides? With an equation, that would be totally fine. I can definitely add 2 to both sides and it would still be in balance. So does this preserve the same imbalance when I add 2 to both sides? 4 plus 2 is 6. 5 plus 2 is 7. So do I get the same relationship? Well, yes, 6 is less than 7. So this one worked. My relationship didn't change when I added 2. So that's good. And I'm going to just trust that I can, in general, add numbers. I'm going to go ahead and consider the similar case. I'll start with the same numbers. 4 is still less than 5. And does this change the imbalance? Is it imbalanced to the other way? If I take away something from both sides, I'll use 2 again. So 4 minus 2 is 2. 5 minus 2 is 3. 2 is less than 3. So it's imbalanced the same way as it was before. I've preserved the inequality. I've preserved which way it's lopsided. It still worked. So now let's look at some other operations. I'll start with 4 is less than 5. That's kind of just the one I'm considering. I could use any numbers here. I'm just trying to see what happens as I try things. Well, what happens if I multiply both sides by 2? 4 times 2 is 8. 5 times 2 is 10. So the gap between these got bigger. They used to be 1 apart, now they're 2 apart. But the direction didn't change. 8 is still smaller than 10. So 8 is still less than 10. And the overall relationship is preserved. It's still unequal in the same direction. Well, what about dividing by 2? 4 is less than 5. 4 divided by 2 is 2. 5 divided by 2 is 2.5. And 2 is still smaller than 2.5. They're closer together than before, but it's still the same direction in that inequality. 2 is still less than 2.5. So everything works, right? There's some weirdness with multiplication and division because we've tried it with positive numbers, but we haven't tried it with negative numbers yet. So what happens if I have a negative? Let's look at that. So I've got 4 is less than 5. And I multiply both sides by negative 2. 4 times negative 2 a negative times a positive like this is going to be a negative. So I have negative 8. 5 times a negative 2 is still going to be positive times a negative, so it's going to be negative, is negative 10. Which one of these is considered to be bigger than the other? Well, we have kind of a casual understanding of this, and then we have a math understanding of this. We think of the bigger negative numbers as being less than the smaller negative numbers because of their position on the number line. If I have a little number line, and the easiest way to get a number line is to turn my paper sideways so that I can cheat and use this line. There's my 0. Here's my negative 5. Here's my positive 5. Obviously, I'm not writing in every single number on the number line. And when we talk about greater than or less than, everything over here is less than everything that's over here. And certainly sometimes in casual conversation, we'll talk about negative numbers as being very large. For example, we'll talk about the national debt getting bigger, even though that would be like a negative number of how much money. So we will casually talk about that, but when we're math talking about it, negative numbers are less than positive numbers, and the bigger the negative number, the more it's small. It's less than. So here we'd have negative 10, negative 8 would be about here. So negative 10 is less than negative 8. So back in the problem we were doing, that means the sign changed because negative 8 is greater than negative 10. So when I multiplied by a negative number, because that changed the sign of my answer, they flip around back on that number line. If I multiply by just negative 1, let's say I have 5 times negative 1, that's going to be negative 5. And so it went from here to here. It flipped on the number line. So they're going to be mirrored around that number line. And so it's going to flip the sign. Similarly, if I divide by a negative number, it's just like dividing by a positive number, except that now I need to have that negative sign involved. So I'll just look up at my previous work, see, oh, that's going to be negative 2. That's going to be negative 2.5. Negative 2 is larger than negative 2.5, so my sign flipped. So the time when you switch the signs is when you're multiplying or dividing by a negative number.